Have you ever found yourself puzzled by pointer arithmetic in C++? It can be a real head-scratcher, especially when you're trying to figure out which element of an array contains a specific member. If that sounds like you, stick around, because today we're diving into a tricky topic: pointer arithmetic using casts to the wrong type. I totally get it. Pointer arithmetic can feel like navigating a maze without a map. You're not alone in this struggle. Many developers have faced similar challenges, especially when dealing with arrays of structs and trying to access their members correctly. Here's the specific question we're addressing today. A user asked, how can I determine which element of an array contains a specific member when using pointer arithmetic? They provided two approaches, but they are concerned about the validity of their code. Sound familiar? Let's break it down together. So what exactly is happening here? The user is trying to find out which vertex of a triangle corresponds to a given coordinate using two different functions. However, they are worried that one of the methods might invoke undefined behavior. Let's explore these methods and understand the implications. And don't go anywhere. By the end of this video, you'll not only understand these methods, but also learn how to avoid common pitfalls in pointer arithmetic. Trust me, you won't want to miss this. To determine if the code is valid, let's first analyze the function vertex A. The user should note that this function casts a float pointer to a struct pointer. This can lead to undefined behavior if the pointer does not actually point to a struct. Next, let's look at vertex B. This function calculates the offset between the float pointer and the start of the triangle array. The user should understand that this approach is safer because it does not involve casting to a struct pointer. The user should also consider the implications of pointer arithmetic. In vertex A, if the float pointer does not align with the struct, it can cause serious issues. However, vertex B avoids this by using the size of the struct for calculations. Finally, the user can conclude that while both functions may produce the expected results, vertex B is the safer and more reliable option. It's important to avoid undefined behavior in programming. Fun fact, did you know that the concept of pointer arithmetic dates back to the early days of programming? It's fascinating how these foundational concepts still challenge developers today. Now let's look at the answers provided by other users. The user points out that the vertex A function breaks the strict aliasing rule. This means that the float pointers used are not valid XYZ pointers, which could lead to undefined behavior. They also mention that in half of the examples, the floats aren't even at the start of an XYZ struct. Regarding vertex B, the user notes that while the cast to const char is valid, performing arithmetic with it across the array is questionable. They suggest that this could lead to undefined behavior, but they are leaning towards the idea that it will work in practice. Let's move forward and look at another answer. The user confirms that the vertex B function is valid. They suggest refining the division of std_ptr diff t by size t, as this could lead to implementation-defined behavior. They note that the result might exceed int max in rare cases with large arrays. To address concerns, the user suggests using assert statements or error checks for pointer limits, but they personally feel it's not necessary. Let's take a moment to review another user's answer. An alternative approach suggested by a user involves changing the type signature to XYZ tsa, where t is a template argument. This allows you to reference either XYZX or XYZY as needed. By using the offset function, you can confidently compute the location of the struct's start, making your code more resilient to future changes. This method does involve some pointer complexity, but it's a common practice similar to the container of macro used in the Linux kernel. Here's a pro tip. Always be cautious when using reinterpret cast. It's powerful, but can lead to undefined behavior if not used correctly. Stick to safer alternatives whenever possible. And there you have it. You've learned about pointer arithmetic and how to safely determine which element of an array contains a specific member. If you found this video helpful, please hit the subscribe button for more insights, and remember to keep experimenting with your code.